In the last video, we created a coin spawner that spawns the coin and moves it to its UI transform in all the render modes and in both the projection views. And this is the code that is responsible for that. We won't be touching the get target position method in this video, so I'm going to collapse this. Tween.position from the prime tween library is responsible for moving the coin from the start position to end position within certain duration that is inside our tween settings here. And once that is done, we are destroying the coin game object. We can also do this with tween.custom. Here we are changing the float value from 0 to 1 within the duration that is inside our tween settings. And this takes in an action that is triggered every time the value is changed. And this action passes a float value, which is the changed value at that point of time. We are using lambda expression to create this action. And here the t represents the changed value. And in the body of this expression, we are setting the coin's position to an interpolated value between start position and end position at interpolation value t. So we have a starting position and an end position. Let's call them point A and point B. And we are interpolating with interpolation t and set the coin's position to these interpolated values as the t goes from 0 to 1. Now I'm going to add one more point here and call this, actually I'm going to call this B and rename this end position to C. And let's also call this control point. All right. I'm going to interpolate between A and B and call this AB and pass some t, and interpolate between B and C called BC with the same t, same interpolation value. So if I interpolate between these 2 points at the same time and pass the same interpolation value, I'll get the interpolated positions something like this. Now let me erase this so it's not confusing. We are no longer interpolating between start and end, right? Now I'm not setting the coin's position to either of these interpolated positions, but I'm going to interpolate between these 2 interpolations and call this AB, BC, and that also takes in the same t. All these 3 interpolations takes the same t and they are interpolated at the same time. So I might get something like this. Now, when you set the coin's position to this interpolation value, I would get a curved path between start and end position. And this is called a quadratic Bezier curve. Let me create a new function for that. This returns a vector 3 and takes in start position, a control point position, and end position, and a float for the interpolation value. First, we need to loop between the start and control point. Next, let's loop between BC, that is the control point, and end point. And finally, we can loop between AB, BC, that would be the final third path that we are looking for. So let's simply return that instead of creating a new variable for that. I'm going to replace the vector3.lerp here with the quadratic Bezier. Now it takes the start position, that's fine. And it needs a control point next. So let's create a new serialized field for that. So let's pass its position. And then we need an end position, and we need to pass the interpolation value. I'm going to create a sphere for the control point so I can see it in the scene view. And after assigning it, let me interplay. And you can see that the coin is currently curving its path. And if I move my control point to other spots, it affects the curve. Now let's work on the gizmos so we can easily visualize its path. Instead of drawing a single line, I'm going to break this into 10 parts. Here I'm going to create point 1 and get the quadratic Bezier curve at the interpolation value I divided by 10, because here I goes from 0 to 9 and the interpolation value can only be within 0 and 1. So if I divide it by the max value that I'm passing here, I'll get that float. And I'm going to do the same thing for the float, but increment the index by 1. And finally, draw a line between point 1 and 2. Now we can go a step further and lerp between two quadratic Beziers, and that is called a cubic Bezier curve. This is also returning a vector 3 and takes in start, control point 1, control point 2, and end points along with the interpolation value. And here we are simply creating a quadratic Bezier between start, control point 1, control point 2, and one more with the control point 1, control point 2, and end, and lerping between those two. Let me replace the quadratic Bezier here with the cubic Bezier, and this needs one more control point. So I'm going to rename this to control point A, duplicate it, and call this control point B, and pass its position here. I also need to update our on-draw gizmos with the cubic Bezier. Let me duplicate this and call it control point B, and assign both the fields. And finally, once the tween is complete, let's go to the second line and call on complete and destroy the coin game object. You can improve their performance by replacing the vector3.lerp with a basic math operations. I'm going to attach this blog post by Vivek, which goes into detail. And if I use this formula for quadratic Bezier curve, we are creating a new variable called 1 minus 1 because we are using this multiple times. So this is more efficient. And let's do the same for our cubic curve. This is a bonus step. If you want a simple curve, something like this, you don't have to go to the trouble of creating control points and using Bezier curves. Instead, you can simply use mathf sine. I've prepared this method called sine interpolate that takes in a start position and end position and interpolation value and returns a vector 3. Here we are simply lerping between start and end, and we are going to perform some more operation to the lerped values y position. So basically, this mathf sine t mathf I oscillates between 0 and 1. And I want the change to be more noticeable, so I'm going to multiply that with a higher value, something like 10, and finally return that modified value. Now let's replace the cubic Bezier with that one. This does not need any control points, so I'm going to remove these two. Now when I spawn the coins, you see that the coin initially travels down and then up. If I move the spawner here, you can notice that. So yeah, if this is what you're looking for, you could simply go with that. Let me know if you have any questions. Like the video if you liked it, and make sure to subscribe. All right then, see ya.